In this videotape in the pre-algebra series, we're going to be working on addition and subtraction of fractions. Now, to add and subtract two fractions, they must have the same denominator. For example, if you have 2/7 and you want to add to it 3/7, these are two fractions with the same denominator. To add them, you combine the numerators, 2 plus 3, get 5, and put it over the common denominator. To add two fractions having the same denominator, you combine the numerators and put it over the common denominator. On the other hand, if you want to subtract two fractions, the same idea, 7/8 minus 5/8. To subtract two fractions having the same denominators, you combine the numerators, 7 minus 5, and get 2/8. Now, 2/8 is not in lowest terms, but using the fundamental principle of fractions, we know that we can divide numerator and denominator by 2. This is 2 times 1 over 2 times 4. Dividing numerator and denominator by 2, we get an answer of 1/4. 2 divided by 2 is 1. 8 divided by 2 is 4. So the rule that we're using is that A over C plus or minus B over C. If you want to take one fraction and add or subtract another fraction having the same denominator, you combine the numerators, either you add them or subtract them, whatever the case might be, and put it over the common denominator. So this is the key rule for adding and subtracting fractions. For addition and subtraction of fractions. Now, I mentioned before the fundamental principle of fractions. Just to remind you, in case you haven't seen the videotape on multiplication and division of fractions where I go over this rule, the fundamental principle of fractions tells us that if we have a fraction, P over Q, we get an equivalent fraction if we multiply the top and the bottom by the same non-zero quantity K. Of course, we're assuming that Q and K are not equal to 0 because we do not divide by 0 in our mathematics. If you have a fraction, if you multiply the top and the bottom by the same non-zero quantity K, you get an equivalent fraction. On the other hand, if you have a fraction, if you divide the numerator and denominator by the same non-zero quantity K, you get an equivalent fraction. It was working from right to left. That was the rule that we used to reduce 2/8 to 1/4 to lowest terms. We took a fraction. We said 2/8 is really 2 times 1 over 2 times 4. We divided top and bottom by 2, the common factor, and reduced it to 1/4. In this videotape, we will also have need to go the other way, not only using the fundamental principle from right to left to reduce to lowest terms, but also from left to right to build to higher terms. You see, the rule that I have given you here is only good for adding and subtracting fractions that have the same denominator. If they do not have the same denominator, we cannot use this rule. So what we have to do is sort of adapt what we're doing. For example, let's say we want to add two fractions that do not have the same denominator. For example, 2/3 and 3/4. What we'll have to do is to first rewrite each of these fractions as an equivalent fraction having the same denominator. Now, what denominator is that? We're going to be looking for the lowest common denominator. That is the smallest positive integer that is a multiple of each of these denominators. If we write down the multiples of 3, multiples of 3, we have 3, 6, 9, 12, 15, and so on. If we write down the multiples of 4, 4 times 1, 4 times 2, 4 times 3, 4 times 4, and so on. We're looking for the first number that occurs in both of these lists of multiples. And of course, the first number is 12. 12 is both a multiple of 3 and a multiple of 4. It is so what we're going to do here is to try to build fractions equivalent to each of the original fractions having the same denominator. In this case, the denominator is 12. 12 is the lowest common denominator, the smallest number that 3 and 4 both go evenly into. Okay? 12 is the smallest multiple of both 3 and 4. Here are the multiples of 3. Here is the multiples of 4. It's also, in this case, the product of the two denominators, but very often the lowest common denominator is significantly smaller than the product of the denominators. Okay, what we want to do is build fractions equivalent to these having the same denominator, namely 12. We want to say that 2/3 is equivalent to some number of 12ths, and that 3/4 is equivalent to some number of 12ths. And the question is, how many 12ths? Well, here's where we're going to be using our fundamental principle of fractions again. We know that P over Q is the same as P times K over Q times K. That is, we can multiply the top and the bottom of a fraction and get an equivalent fraction. So what we have to do is ask ourselves, what did you do to the 3? What did you multiply 3 by to get 12? Well, to go from 3 to 12, you'd have to multiply by 4. Since we multiplied the denominator by 4, we'd also have to multiply the numerator by 4 to get an equivalent fraction. In other words, if you say that you want to have a denominator of 12, you have to realize that 12 is 3 times 4. Therefore, since we have multiplied the denominator by 4, we have to also multiply the numerator by 4. Because according to the fundamental principle, 2/3 is the same as 2 times 4 over 3 times 4. Now, of course, we do not cancel the 4s and go back to 2/3, because our goal is to build fractions equivalent to the original fraction, but having a larger denominator. So we see that this is 2 times 4. This is 8 over 12. 2/3 is equivalent to 8/12. Similarly, 3 times 4, we want to change that into a certain number of 12ths. Well, to go from 4 to 12, you have to multiply by 3. If you're going to multiply the denominator by 3, you also have to multiply the numerator by 3. So we have 3 times 3 divided by 4 times 3. We do not reduce it to 3/4 because our goal is to build to 12ths. This gives us 3 times 3 over 4 times 3, or 9/12. So we now know that 2/3 is equivalent to 8/12 by the fundamental principle of fractions, and that 3/4 is equivalent to 9/12 by the fundamental principle of fractions. In the first case, we multiplied top and bottom by 4, which was legitimate because you can multiply the top and the bottom of a fraction by the same quantity. In the second case, we multiplied top and bottom by 3. We now have two fractions with the same denominator, which looks like the problems that we started with. If you have two fractions with the same denominator, you combine the numerators when you want to add or subtract and place that over the common denominator. So to add or subtract two fractions with the same denominator, combine the numerators and place over the common denominator, but they must have the same denominator. They didn't originally, but we were able to get around that by building fractions equivalent to the original fractions that had the same denominator. So now we're talking two fractions with the same denominator, combining the numerator, 8/12 plus 9/12, 8 and 9, that's 17/12, which can be either left like that or rewritten as 1 and 5/12, because this really means 17 divided by 12. It goes in once with a remainder of 5, and you rewrite this as the quotient plus the remainder over the divisor, 1 and 5/12. Okay, let's try another example. Let's say we want to add 3/8 and 5/6. These are two fractions. They do not have the same denominator. So our first step will be to find the lowest common denominator. The smallest number that is a multiple, the smallest positive integer that is a multiple of each of those denominators. Okay? Some people are able to do this in their head. Some people need to write some of it down. Let's write down the multiples of 8. We have 8 times 1, 8 times 2, 8 times 3, 8 times 4, 8 times 5. Let's write down the multiples of 6. 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5. We have been able to locate a number that's in both of these lists. The smallest number that's in both lists is 24. Okay, if we were to continue on, we will find other common multiples. But we're looking for the smallest of these, the least common multiple. In this case, it's 24. 48 is also a common multiple, but it's not the smallest. Okay, now it's not a catastrophe if you decide to combine over 48. 8 goes into 48, and 6 goes into 48. In the preceding problem, we had thirds and fourths, and the product of the denominators, 12, was also the lowest common denominator. Here, the product of the denominators, 48, is actually larger than we need. Okay, but nothing terrible will happen to you if you use 48, except at the end, you'll probably have to reduce your answer to lowest terms. Even this way, you may still have to reduce it to lowest terms. Okay, so the smallest common multiple is 24. And we're going to build fractions equivalent to the original fractions, but having the denominator of 24. Let's see. We want to change 3/8 into 24ths. And we want to change 5/6 into some number of 24ths. Well, what do you have to do? What do you have to multiply 8 by to get 24? 24 is 8 times 3. If you're going to multiply the bottom by 3, you have to multiply the top by 3 as well. So since 3 over 8 is the same as 3 times 3 over 8 times 3, this is equivalent to 9 24ths. Similarly, what do you have to multiply 6 by to get 24? You have to multiply it by 4. This is 6 times 4. If you're going to multiply the bottom by 4, you have to multiply the top by 4 as well. That's what I mean by the fundamental principle of fractions. You multiply the top and the bottom by the same quantity. This gives us 20 over 24. So we were able to rewrite 3/8 as 9 24ths and 5/6 as 20 24ths, giving us now two fractions having the same denominator. So to add them, we can combine the numerators, 9 plus 20, 29 over 24, or 1 and 5 24ths as an answer. Either one would be correct. As I said, if you combined over 48ths, you would be able to do it, except you probably would have to reduce to lowest terms at the end. Okay, let's try a subtraction. 5/8 minus 7/20. One fraction, take away another fraction. To do this, of course, the fractions are going to have the same denominators. 8 and 20 to get the lowest common denominator. Let's look at multiples of 8 and at multiples of 20. Multiples of 8. 8 times 1, 8 times 2, 8 times 3, 8 times 4, 8 times 5, 8 times 6, so on. Multiples of 20. 20 times 1, 20 times 2, 20 times 3. And I've seen that there is a number in both lists, namely 40. That's going to be the least common multiple for 8 and 20, the smallest number that is a multiple of both of these. So 40 will also be the lowest common denominator. If you use The product of the denominator is 160. I think you make the problem harder than it has to be, okay, although you can do it. In a pinch, use the product of the denominators rather than not having any lowest common denominator at all, rather than, excuse me, than not having any common denominator. If you can't get the lowest common denominator, just take any common denominator. But preferable, it's definitely preferable to have the lowest common denominator. So let's see if we can't do the work a little more concisely here. You have to say, what did you multiply the 8 by to get 40? You multiply 8 by 5, so you have to multiply the numerator by 5 as well. Since you've multiplied the denominator by 5, you have to multiply the numerator by 5. So 5/8 is equivalent to 25 over 40. I multiplied the bottom by 5, so I have to multiply the top by 5. On the other hand, what do you do to 20? How do you multiply 20 to get 40? You multiply it by 2. Since I multiplied the bottom by 2, I have to multiply the top by 2 as well. So in the first fraction, I multiplied top and bottom by 5. In the second fraction, I multiplied top and bottom by 2 to get equivalent fractions having the same denominator. So now I have 25 40ths minus 14 40ths. They have the same denominator, so I simply combine the numerators and put it over the common denominator. 25 minus 14 gives me 11. So I have an answer of 11 40ths. For my next example, let's try one where we add and subtract in the same problem. 5/6 minus 3/10 plus 2/15. What we need to do is determine the least common denominator here. And to build fractions equivalent to each of these having the same denominator. So we're going to need now multiples of 6, multiples of 10, and multiples of 15. As far as how high do you have to go with the multiples, well, you keep going until you find a number that's common to all of the lists. Okay, 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, 6 times 6. And we'll stop for the moment. If we need to go on later on, we will. But for the time being, let's just stop. Multiples of 10. 10, 20, 30, 40, so on. Multiples of 15. 15 times 1, 15 times 2, 15 times 3. And we already see that there is one number that occurs on all of the lists. The smallest number that occurs on all of the lists is, of course, 30. So 30 is going to be the least common denominator here. What we're going to have to do is build fractions equivalent to each of the original fractions having this denominator of 30. In each case, you're going to have to ask yourself, what did you do to this denominator to get that one, and do the same thing to the numerator? By that I mean, what did you multiply this denominator by to get that one? Well, to go from 6 to 30, I had to multiply by 5. Since I am multiplying the denominator by 5, I have to multiply the numerator by 5 as well. So 5/6 is equivalent to 25 30ths. Similarly, what do you have to multiply 10 by to get 30? You have to multiply it by 3. So you have to multiply the numerator by 3 as well. 3 times 3 giving you 9. And what do you have to multiply 15 by to get 30? You'd have to multiply 15 by 2, so you have to multiply the numerator by 2 as well. So we were able to write each of these fractions as an equivalent fraction having the same denominator. Okay, now don't make the mistake of reducing any of these to lowest terms. You'd be going in the wrong direction. We know they're not in lowest terms. The important thing, however, is that they all have the same denominator. So we can combine the numerators. 25 minus 9 plus 4 all over 30, or 25 and 4, 29 minus 9, 20 over 30, which of course can be reduced to lowest terms by dividing numerator and denominator by 10 to get a final answer of 2/3. Now, sometimes you're called upon to perform addition and subtraction of fractions while the numbers are still in mixed number form. Okay, if that's the case, for example, let's say you have 16 and a third, take away 4 and 5 sixths. I think the easiest way for us to go on this, although not the only way, okay, some people do work in the mixed form, okay, but what I'm going to recommend, same thing I recommended for multiplication and division of fractions, is to change each mixed number into an equivalent improper fraction, okay, to put them into fractional form, in other words, P over Q form, and then to proceed by the methods that I've shown you in this tape. So while I'm aware of the fact that some of you may have learned the way of working with these in the mixed form, okay, that's only good for addition and subtraction. For multiplication and division, you really have to turn them into equivalent improper fractions. So I think it's best just to take the idea that whenever you're working with mixed numbers, first turn them into fractional form, you know, as improper fractions, and then to go on from there. So as such, I'm going to recommend the following. I'm going to turn these into fractional form. The way to do that is to say 16 times 3 is 48 plus 1 is 49 all over 3. This is 16 and a third is equivalent to 49 thirds minus, now 4 and 5, 6. You say 4 times 6 is 24 and 5 is 29 all over 6. So 16 times 3, 48 plus 1, 49 all over 3. 4 times 6, 24 and 5, 29 all over 6. Rewrite them as improper fractions, equivalent fractions, and now proceed. Now, the lowest common denominator in this case is not 18, which is the product of the denominators, but really just 6. In other words, if you look multiples of 6, 6, 12, 18, multiples of 3, 3, 6, 9. 6 is the smallest number. That's a multiple of each. So we will rewrite these as equivalent fractions having the denominator 6. What do you have to do to 3 to get 6? You have to multiply it by 2. So you have to multiply the top by 2 as well. 49 times 2 gives us 98. So 98 over 6. Here, it's already in the form with the denominator 6. Or you could say, I multiply 6 by 1 to get 6, so I multiply 29 by 1. In other words, you leave it unchanged. So now I have two fractions with the same denominator. I combine the numerators. 98 minus 29 over 6, which is going to be 69 over 6. And it can be either left in that form as a so-called improper fraction, although there's really nothing wrong with that, or to say how many times does 6 go into 69. Well, 6 goes into 6 once. 6 goes into 9 once. Remainder 3. So it's 11 and 3/6, or 11 and 1/2, because you can divide numerator and denominator by 3 to get 1/2. So you either write it as 69/6 or 11 and 1/2. Either is correct. Let's also try the following. 10 minus 2 and a third. Now, in order to do this, think of 10 as 10 over 1, so that it's in fractional form. And 2 and a third is, of course, 2 times 3, 6 plus 1, 7 thirds. The lowest common denominator in this case is 3. Because 1 and 3 both go, 1 and 3 both have 3 as a multiple. And 7 thirds is already in the correct form. To go from 1 to 3, you'd have to multiply by 3. You'd multiply the numerator by 3 as well. So to rewrite 10 as 30 thirds, and then to subtract 7 thirds, giving us, now they have the same denominator. So to combine the numerators, 30 minus 7, 23 over 3, 23 thirds, or how many times does 3 go into 23? 7 times, with a remainder of 2, so 7 2/3. Either one of these is acceptable as an answer. Sometimes we have problems that involve all the arithmetic operations in the same problem. For example, addition, subtraction, multiplication, and division of fractions all in one. Let's look at a typical example. 1/2 plus 1/3 over 2/3 minus 1/4. Okay, a fraction like this is called a complex fraction. A complex fraction would be a fraction where there are fractions themselves, where the numerator or the denominator has fractions in it as well. It's a fraction, and either the numerator or the denominator, or possibly both, contain fractions. We call that a complex fraction. Now, I'm going to show you 2 ways of handling this problem, and you can decide to use either one. The important thing, of course, is to be able to handle problems like this. Okay, method 1 is the following. 1/2 plus 1/3 divided by 2/3 minus 1/4. In method 1, you work separately with the numerator and with the denominator. You view the numerator as an addition of 2 fractions. You view the denominator as subtraction of 2 fractions, both of which you've learned how to do in this tape. So let's see what we have. 1/2 plus 1/3. In order to add those fractions, you'd have to find the lowest common denominator, which happens to be 6. You can write down multiples of 2, 2, 4, 6, 8, 10, so on, multiples of 3, 3, 6, 9, 12. 6 is the least common multiple of 2 and 3. To go from 2 to 6, you'd have to multiply by 3, so multiply the numerator by 3 as well. In other words, 1/2 is equivalent to 3/6. Similarly, to go from 3 to 6, you'd have to multiply by 2, multiply the top by 2. 1/3 is equivalent to 2/6. So the numerator, you work out the numerator. The numerator is 3/6 plus 2/6, which is 5/6. Of course, we still have a denominator to worry about. We forget about the numerator. Now we're working on the denominator. We have, once again, 2 fractions. Now we're subtracting 2 fractions. They need to have the same denominator for us to proceed. Earlier today, we had a problem involving thirds and quarters, and we saw that the lowest common denominator was 12. What do you have to multiply 3 by to get 12? You'd have to multiply by 4. Let's multiply the numerator by 4 as well. So we get 2/3 equivalent to 8/12. What do you have to multiply 4 by to get 12? You have to multiply by 3. You must multiply the numerator by 3 as well. So 2/3 minus 1/4 is equivalent to 8/12 minus 3/12, which is, now these are 2 fractions with the same denominator. Combine the numerators and place them over the common denominator. That gives us 5/12. Okay, now we have 1 fraction divided by another fraction. Okay, in the videotape on multiplication and division of fractions, we learned that to divide 2 fractions, what we do is we invert and multiply by the divisor, or in this case, the fraction in the denominator. So instead of 5/6 divided by 5/12, we change it into 5/6 times 12/5. Instead of dividing by 5/12, we invert and multiply by 12/5. We can multiply the tops and divide by the product of the bottoms, or we can first choose to cancel out common factors. You can divide 5 by 5 and get 1, 5 by 5, get 1. Divide numerator and denominator, in other words, by 5. Similarly, you could divide numerator and denominator by 6. 6 divided by 6 is 1. 12 divided by 6 is 2. To get 1 times 2 over 1 times 1 for a final answer of 2. Of course, if you had just multiplied, you would have gotten 60 over 30, which is also 2. So this is method 1. Method 1 is to handle the numerator problem separately until you get an answer. handle the denominator problem separately, and then perform the division by inverting and multiplying. So we're really doing addition, subtraction, multiplication, and division all in the same problem. Let me now show you the other method for solving this problem. Method 2. Okay, in method 2, we look at all of the little denominators in the problem, top and bottom. 2, 3, 3, and 4, and we look for the least common denominator for all the little denominators, or the least common multiple of 2, 3, and 4. The smallest number that is a multiple of 2, 3, and 4. You look at, in other words, multiples of 2, multiples of 3, and multiples of 4. The first number to appear on all of those lists happens to be 12. And what we do is we multiply numerator and denominator by that number. We multiply the top and the bottom by 12. Remember, the fundamental principle of fractions says we can multiply, we get an equivalent fraction if we multiply the top and the bottom by the same non-zero quantity. Now, I want to multiply using the distributive law. In other words, it's 12 times 1/2 plus 1/3. In parentheses, it's 12 times 1/2 plus 12 times 1/3. Everything has to get multiplied by the 12. So it's 12 times 1/2 plus 12 times 1/3 all over. Now, once again, distribute the 12 through the parentheses. 12 times 2/3 minus 12 times 1/4. So everything gets multiplied by 12. 12 times 1/2 plus 12 times 1/3 over 12 times 2/3 minus 12 times 1/4. Remember, the 12 is really 12 over 1. So what we've done here is given ourselves some multiplications of fractions to handle. 12 over 1 times 1 over 2. You can first say divide numerator and denominator by 2, 2 divided by 2, 12 divided by 2, 6, and you get 6 for the answer over there, plus dividing numerator and denominator by 3 here, or 12/3 is equivalent to 4. Here, 3 divided by 3 is 1, 12 divided by 3 is 4, 4 times 2 is 8, minus 4 divided by 4, 12 divided by 4, 3 over 1, so we have 3. So that gives us now, see, we picked 12 because we knew each of the denominators would divide evenly into it. So then when we did the multiplication, we would only be left with whole numbers here. All right, 6 plus 4, 10 over 8 minus 3, 5, 10/5, of course. Dividing top and bottom by 5 gives us 2. Okay, so you might prefer this method. Here you don't have to worry at the end about dividing two fractions, inverting and multiplying. What you do is have to first find the least common multiple for all of these numbers, 2, 3, and 4. It's 12. Multiply top and bottom by that, remembering to distribute it through the parentheses. And then what you're left with is one whole number over another, which you can then reduce to lowest terms. And one integer over another. OK, let's try another example. Involving complex fractions. Okay, simplify the following. 2/3 minus 1/8 over 1/4 plus 1/3. Okay, let's quickly do it both ways. By method 1, we will work with the numerator separately. We have thirds and eighths. The lowest common denominator will be 24 in this case. 3 times what is 24? 3 times 8 is 24. If you multiply the bottom by 8, you have to multiply the top by 8 as well. 2 times 8 giving you 16. 8 times what is 24? 8 times 3 is 24. If you multiply the bottom by 3, you have to multiply the top by 3. So we have 16 24ths minus 3 24ths, or 13 24ths on top. And in the bottom, for fourths and thirds, the lowest common denominator would be 12. 4 times what is 12? 4 times 3 is 12. You multiply the bottom by 3, multiply the top by 3. 1/4 is equivalent to 3/12. 3 times what gives you 12? 3 times 4 is 12, so multiply the top by 4 as well. So we have on the bottom 3/12 and 4/12, which is 7/12. Now, 13 24ths divided by 7/12. You'd have to invert and multiply by 12 sevenths. Looking for common factors, 12 is a factor common to the numerator and the denominator. Dividing the numerator by 12, dividing the denominator by 12, we get 13 times 1 over 2 times 7 for an answer of 13/14. Now let me just show you the problem with method 2. Two-thirds minus 1/8 over 1/4 plus 1/3. If you were to write out the multiples of 3, 4, and 8, you would see that the first number to occur on all three lists would be 24. So we will multiply numerator and denominator by 24. So it'll be 24, don't forget to distribute it, 24 times 2/3 minus 24 times 1/8 over 24 times 1/4 minus 24 times 1/3. To distribute 24 through the top parentheses and the bottom. 24, of course, is 24 over 1. So we have, in this case, 4 multiplications of fractions to contend with, but each one will result in an integer answer. Okay? 3 divided by 3 gives you 1. 24 divided by 3 gives you 8. So 8 times 2 is 16. Minus 8 goes into 24 3 times, so we have 3 over 1. 4 goes into 24 6 times, so we have 6 over 1. And this is a plus. Excuse me. This is 1/4 plus 1/3. So this should have been a plus down here. And a plus over here. And 3 goes into 24 8 times, so we have that. So 16 minus 3 gives us 13 on top, 6 and 8, 14 on the bottom, for an answer of 13/14, which of course is the same answer we got with method 1. Just want to mention that this was a plus. This should have been a plus. This is a plus. Okay. For the last problem today, I'm going to give you a review problem to try. And I'm going to write down the problem. Why don't you shut off the machine or put it on pause, see if you can do the problem, and turn me back on when you have the answer. The problem is the following, to review what you've learned in today's tape. 4 2/3 take away 2 1/5. 4 2/3 minus 2 1/5. All right, we have a problem here involving mixed numbers. As I mentioned earlier, the best thing to do, although not the only way to handle this, but I would recommend this, is to turn each fraction into an equivalent improper fraction. Okay, 4 2/3 is 4 times 3, that's 12, plus 2, 14 thirds. And 2 1/5 is 2 times 5, 10, plus 1, 11 fifths. So now we're dealing with fractions in the form a over b minus c over d. In order to add or subtract two fractions, however, they must have the same denominator. So what we need to do is to find the lowest common denominator. To write down multiples of 3 and multiples of 5 until we get one number occurring on both lists. 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, and so on. 5 times 1, 5 times 2, 5 times 3. The first number to occur on both lists is 15. 15 is the lowest common denominator. It is also, in this particular problem, the product of the denominators. But as we've seen in the videotape, very often something smaller than the product can be used. However, in a pinch, you can always use the product of the denominators, at least for a common denominator, to get yourself started. Okay, ask yourself, what do you have to multiply 3 by to get 15? You have to multiply 3 by 5. Therefore, you have to multiply 14 by 5 as well, and that gives us 70. What do you have to multiply 5 by to get 15? You have to multiply 5 by 3, so you have to multiply 11 by 3, which gives us 33. So we have 70 fifteenths minus 33 fifteenths. We have now the same denominator, so we can combine the numerators. 70 minus 33 all over 15, or 37 over 15. And that can be either left in that form as a so-called improper fraction, or reduced or written as a mixed number. How many times does 15 go into 37? Twice the remainder of 7. So also be written as 2 7 fifteenths. So either this answer or that. 37 fifteenths or 2 7 fifteenths. And that brings us to the end of this tape.